This example comes out of section 8.1, understanding. So in this example, we're asked to graph y equals 3 to the x and its inverse. So y equals 3 to the x, hopefully is a review from the last chapter. It's an exponential growth function. It's going to increase as I go to the right. It has an asymptote at y equals 0, has a point at 0, 1. That's y-intercept. Goes through 1, 3, for example, 2, 9. You could put in however many points you wanted to that would satisfy the equation. So for my purposes, those 3 points will be plenty. So 0, 1, 1, 3, and 2, 9. I'll put in my little table of values. So there's a few ways we've looked at doing the inverse, but definitely, hopefully, the first thing you do is you think, oh, I got to switch x and y. So x equals 3 to the y is the equation of the inverse, or an equation for the inverse. If I looked at its table of values, I literally switch the coordinates. So 0, 1 becomes 1, 0. I've got 3, 1. And I've got 9, 2. Now, x equals 3 to the y is a nice looking enough function, but usually we write these as y equals. The equivalent equation is y equals log base 3 of x. If you've been following along with what a log means, you'll realize that those two equations have the same meaning, that this inverse and this inverse mean the same thing. So what does the graph look like? Well, we used to have an asymptote at y equals 0. We now have an asymptote at x equals 0. So x equals 0. We have a curve that goes through 1, 0. We have a curve that goes through 3, 1, 9, 2. Put some points. And I have a graph that looks something like this. And if you look closely or carefully, you'll see that it is the reflection of the original graph about the line y equals x, which is what we've seen whenever we've done inverse functions or inverses of functions. So the exponential function and the logarithmic function are related in that one is the inverse of the other.